Oh, hi there. Inequalities? Sure. All right, when we approach inequalities, we're solving just like it's an actual equation. Same process until the end. There's a couple other rules that you're going to have to pay attention for. Okay, here we go. First things first, simplify each side before moving things side to side. So I'm going to essentially just distribute here. Do not be afraid of fractions. Tops, bottoms. It's cake. 2 over 3. Minus, now notice this will give me a 3 over 3, which is a 1, and we continue. Now, get variables on one side, numbers on the other. So I'm going to add the 1, and we're left with 2/3 y is greater than y plus 3. But at this step, I need to get all my y's on the same side, so I'm going to bring this y over. Now, essentially, I'm bringing a y. That's 1 y. So it cancels here, and we know we're just going to be left with 3. Over here, many of you are struggling with this. Listen, this is just 2/3 minus 1. That's all that is. So off to the side, instead of 1, I'm going to make that a 3 over 3. Notice that is the exact equivalent, but I have the same denominator. So I'll be left with a negative 1/3 y. So up until now, everything's been exactly how you would see an actual equation. Here there's some rules that are a little different. To solve this part, I have to multiply by the reciprocal. That's normal. But the reciprocal here is negative 3. So when you multiply each side by either a negative or you divide by a negative, you are going to have to switch the signs. That's one of the rules you'll have to know about. Anytime you multiply or divide by a negative, the signs will switch. Yeah, you're welcome. We're left with y is less than negative 9. All right, graph interval notation, and we're done with this problem. Graphing, easy peasy. We start with a negative 9. Now you already know this because we've talked about it before, but if it is not equal to, it is an open circle. If it was equal to, it would be closed, but it is not, so it is open. And we are less than, so we are left than. This graph tells the reader all numbers shaded, all numbers less than negative 9 will make a true statement for our original inequality. Okay, interval notation you know as well. This approaches the left side and never stops, so it approaches negative infinity and goes all the way up to negative 9, but it is not a closed circle, it is not equal to, so it is not included, which is why we have another parenthesis. All right, 1 done. Marker drop. Second one, another marker. Here we go. Again, simplify each side before moving side to side. And the second thing you need to look for, how dare you add 3 and 2 together? I've seen this from many people. You're not going to add these together. Distribution is a form of multiplication, which comes before addition. PEMDAS, the M before the A. Yes. Distribute. We get a 3 plus 2m plus 10 is greater than or equal to 4m plus 12. All I did was distribute. Don't start moving things yet. Combine like terms. Now we have a 2m plus 13 greater than or equal to 4m plus 12. All right, we're going to get numbers on one side and variables on the other. I'm going to bring my variables to the right side so that they stay positive. And I'm actually going to two-step here. I'm going to do 2 things at once just because I'm fancy. Here we go. Minus the 2m to get all my variables on one side, and minus the 12 to get all my numbers on one side. By doing this, I'm doing it in one step, and I'm keeping things positive. We're left with 1 greater than or equal to 2m, 1 step away, divide by 2. 1/2 greater than or equal to m. Now, a couple things at this step. Yes, it's a fraction. Shush, you're fine. You know how to deal with fractions. 2, you may have had that teacher who was like, oh, whatever way the arrow's pointing, that's where you shade. I don't want this to be too harsh, but they were a liar because you have to read it from the perspective of the variable to understand how to graph. So if I'm reading this from the perspective of the variable, this is m is less than or equal to 1/2. Think that way when you start graphing, okay? So when I get to my number line, I'm not picky. Go ahead and throw that 1/2 on there. Now, some teachers, and again, this is fine if they do, they'll make you put a 1 and a 0 and mark it right in between. You understand that's the exact same thing as 1/2. Uh-oh, equal to means it's a colored in circle. Now again, if you're doing this too quickly, you're going to miss this. Oh, it's pointing to the right. Go to the right. You're a liar. Read this from the perspective of the variable. M is less than or equal to 1/2. I am less than. I am a left than. And there's our graph. Again, very similar. We're approaching negative infinity. And we go all the way up to 1/2, but this time we got it. The bracket signifies that it is a part of our solution. It is a captured value. That's why we have the bracket. 2 for 2. Let's get it. Last one. Mother fraction. Now, you need to be careful. First, on how you say mother fraction. Second, so many of you want to just subtract a 2. You can't do that. That's not a normal 2. That 2 is being divided by 5, and so is the negative 3x. So if you don't like fractions, let's do something about it. How would you get rid of that 5 on the bottom? Multiply. You do that to both sides. You multiply to get rid of this. I've seen far too many of you starting to distribute. The purpose of this was to get rid of the bottom. Okay? We're left with 2 minus 3x less than or equal to 15. And now it's cake. It is right up our alley. Get the variable alone. Positive 2, bring it over by subtracting it. Negative 3x less than or equal to 13. What are we doing here? Dividing by what? Negative 3. Don't sleep on that. We're about to flip. Right now, we have a less than or equal to. See it? And we divide it by a negative. We're going to flip it. We're left with x greater than or equal to. Now, you can do a variety of things here. You can leave it negative 13 over 3, but that's very tough to see on a line graph. So I recommend a mixed number. 3 goes into 13 4 times with 1 remaining. That is something I know where to find on an actual line graph. It's just a little bit past the negative 4. So when I go to graph, this time I'll do it the way that some teachers may want you to. If this is negative 4, this is negative 5. Remember, as we go left, they're going to get larger negatives. It's probably right around here, and it is a closed circle, because I am equal to. Uh-oh, greater than. I am greater than. I'm going to go to the right side. If I'm greater than, I go to the right side. That's right. You just got to say it with an Australian accent, and it gives you the answer. And that's where my shading lies. Last step, bell time. Let's get it. It starts this time. Remember, interval notation is least to greatest. It starts at negative 4 1/3. That's the smallest value, and we own it. We capture it. The largest value, well, it does not stop going to the right, so it goes to infinity. 3 quick examples on how to deal with linear, well, actually just with solving regular inequalities. How to solve, the rules, how to graph on a number line, and interval notation. 3 marker drop. Walk off!